Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to evaluate an improper integral. All right. In the previous exercise, we were checking if an integral is proper or improper. So today we're going to learn how to evaluate improper integrals. So you can pause the video at this moment and you can start checking why each integral is improper to start with by using the techniques that you learned in the previous video. Okay. So once you decide that, after you pause the video, you check, and after you decide that these integrals are all improper, so we have a recipe to handle each type of improper integral. So let me explain that real quick. All right, here we go. In this particular exercise, we're going to have improper integrals with infinite integration limits. That's why you call those integrals to be improper. So let's see what cases you have. So if f is continuous on the interval of integration, let's say in the first case is a at infinity, so we are going to replace the upper limit, which is infinity, by b, another letter, and we're going to let that b go to infinity outside the integral. So if you look at the integral on the right-hand side, that is a proper integral now because a and b are finite numbers. Once we are done integrating the proper integral by using the fundamental theorem of calculus, then we're going to pass the limit. So this is a two-step process. First, splitting this integral into a limit and a proper integral, and then evaluating the definite integral by using the tools that we learned so far. That could be the application of integration by parts, U substitution, or basic integration rules, even partial fraction. Okay, and then we're going to pass the limit for the final output of the proper integral. Okay, and the second case is that you have the lower limit being negative infinity. So what we do is we're going to replace that lower limit by another letter, let's say a, and now I have integral from a to b f of x dx. That's proper, and I'm going to let a go to minus infinity. So in the first two cases, we have either infinity or minus infinity popping in one of the limits. So what if two of them pop at the same time? So you're dealing with the integral minus infinity to infinity f of x dx. So that means I'm going to split that into two integrals. Here, I choose a c in between negative infinity and infinity. That's totally up to you, a number. Okay, so it could be 0, 1, 2, depending on what your function is. So I split that integral into two parts. One is from negative infinity to c, and the other one is from c to infinity. Okay? So, and the first one, as you see, minus infinity to c is the second kind on the list, and the c to infinity is the first kind in the list. It's the first bullet item. Okay? So I'm going to show you more details within the video, but this is already a long intro. Let's get started. All right, let's start with part A. We have 1 over x minus 1 to the fourth, and the interval of integration is 3 and infinity. So I can see that this is an improper integral because one of the limits of the integral integration is infinity. So and the function is continuous. The function doesn't have any problem within the interval of integration. So I can go ahead and write that the interval of integration is 3 infinity, and 1 over x minus 1 to the fourth is continuous on that. Okay, so we have no problem with that, but just because we have one of the limits to be infinity, so we're going to treat it the way it's explained in this table here. So we have continuity, check mark, and then we have one of the limits to be infinity. So what we're going to do is that we're going to make it look like a proper integral by replacing b by infinity and taking the limit after we are done with this integration, definite integration. Okay, so it's a two-step process. First, we're using the fundamental theorem of calculus to evaluate this definite integral, and then the integral is going to depend on, the result is going to depend on b, and we're going to pass the limit. Okay, so here we go. This integral here is equal to, okay, so we just put the limit here, and we're going to replace
the top limit, upper limit by b. So that means that first I need to take care of this integral. Okay, so let's rewrite that integral. In fact, why don't we use the u substitution real quick, and then I will just take care of this integral here. In fact, the indefinite version of that. Once we have it, we can work on the fundamental theorem of calculus together with the limit operation. Okay, first, let's use the u substitution here for u equals x minus 1. So that du equals dx. Okay, so this integral turns out to be du over u to the fourth, or I can write it with the power form u to the minus fourth. Okay, du, so that I can use the power rule for integration. So that's u to the minus 3 divided by minus 3. So that ends up being negative 1 over 3 u cubed, which is x minus 1 cubed. Okay, you can also put plus c. We won't need that, but just for your own reference. Okay. All right, so let's go back here and use the fundamental theorem of calculus. Minus 1 over 3 x minus 1 cubed from 3 to b. Okay. So plugging in upper limit yields minus 1 over 3 b minus 1 cubed. Okay. Minus 1 over, when you plug in 3, that's 2 cubed, that's 8, 24. Okay. Let me just clean this part a little bit. Okay, good. What I'm going to do now is passing the limit. But as you see, that 1 over b minus 1 quantity cubed is going to tend to 0 when b approaches infinity. So essentially, this limit is going to converge to 1 over 24. Okay, minus 1 over 24 is plus, and this term approaches 0, right? So it's in fact 0 minus 1/24, and that's exactly equal to 1 over 24. Okay, so this is step-by-step approach. Just follow through that. Again, we replaced the upper limit infinity by b, and we wrote this improper integral as the limit of a proper integral. Okay, so for that reason, we first had to find the antiderivative of 1 over x minus 1 quantity power 4. Okay, and once we're done with that, we use the first fundamental theorem of calculus here to plug in upper and lower limits of the integral. Okay, and finally we pass the limit. So it's a combination of many different things that we used earlier. Okay. All right, so for part B, please move on to the next video. I'll see you there. Bye.